Hello everyone, this is DSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is evaluate reverse Polish notation. Let's jump into the problem statement. You are given an array of string tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. Okay, and these are certain points that you have to take care of while you're solving the problem. So the first thing that comes into our head is what is this reverse Polish notation? So basically reverse Polish notation is a mathematical notation, right? So in this, the operator comes after the operand. Now what are operands? See, whenever you have any mathematical equation, right? So how do you write it? You write 4 plus 5 or 3 divided by 2, right? So here, if you see 4 and 5, these are the operands and the plus is the operator, right? Similarly, in this case, 3 and 2 are the operands and divide is the operator. So basically, this is how we represent in mathematical form, right? But when you talk about the reverse Polish notation, right? In that case, what happens is the operator comes after the operand. So that means if I have to represent 4 plus 5, it will be something like 4, 5, and then the operator. So that means the operands, which were 4 and 5, will come before the operator. Similarly, if we had something like 3 divided by 2, then we'll have 3, 2, and at the end we'll have the sign of division. Okay, I hope you understand. So we know that we'll be given a vector, right, which has strings inside it, and it is basically containing the reverse Polish notation. What I need to do is I need to use this reverse Polish notation and then return an integer value. Okay, so now let's take an example and discuss its approach. So basically, I can consider that, let's take an example, right? So for the purpose, let's have something like 4, 13, 5, and then we have a operator that is division and the operator that is an addition. Okay, so this is given to me in the form of a vector, and these all individually are strings in themselves. Okay, so this is something that has been given to me in the input. Now what I have to do is, as I know that this is in reverse Polish notation, I need to get the final integer answer from it, right? I need to get the integer answer from it. So how are we going to do this? See, it's a very easy question, though it has been tagged as medium on Leetcode. It has a very subtle approach. If you just think for a bit, you will be able to understand it, but don't worry, let's discuss it. So basically, if I tell you that, I can see that this vector that has been given to me, it has two things, right? The first thing that it has is the number. For the time being, just forget that you've been given strings. It is okay. We know that we can make a string into a number using a STL function, that is stoi, right? String to integer. So that is something sorted. So for the time being, just assume you've been given numbers and the operator, right? So what are the two things that my vector has? So the first one is the number, or you can say the operands, and the second thing that it has is the operators. Okay. So basically, if somehow I could basically divide them, right? Divide these two into two different categories. And for example, I'll do something like, I'll say, okay, you're getting an operand, put it in a certain data structure. You get a 4, right? Put it here. You move forward, you get a 3. 13, sorry, you'll put it here. You'll move forward, you'll get a 5. Again, it's an operand, put here. As soon as you get something like an operator, right? What happens in reverse Polish notation is, as we know that I said that if I have something like 4 plus 5 in mathematics, so that is represented as 4, 5 plus. So that means if I have found an operator here, right, this was the operator that I had. So these two, just the two values before it, right? So two values before it, or I can say something like two last values or elements, right? I need these to compute the final answer, that would be 4 plus 5, and then get an answer something like a 9, right? So I'll say as soon as you come across an operator, right? So get me these two last values. Okay, now I think I've given a very big hint. What is this telling me? Last value. Which data structure do I need to use? I need to use a stack. Why? Because stack works on the implementation of LIFO. What is LIFO? It says last in will be the first out. So it means that whatever is on the top, whichever thing was added the last, will be given for processing the first, right? So that means 5 will be given first for processing. And as we know that when we are working with the operator, right? So we will be needing two operands in this case, right? So I'll pop out, after popping out 5, I'll pop out 13. And I saw that I got a division, right? So we'll be dividing these. Then whatever result I get, right? After getting whatever result, so that will be, say, 13 by 5, right? Whatever result I get, I like have a certain result, I'll again push it back here, right? So after pushing it here, I'll again move forward because I worked here, I'll come to plus. Then I'll use this answer, and now my pointer, because we have to pop out 2, right? So first my answer came out, then my pointer was pointing to 4. 4 is popped out, right? And this will give me as the final answer, right? I hope the approach is clear, right? It is very, very easy. I'll quickly code it, then we can have a dry run, and then we'll talk about its time and space complexity. Okay, so this is the code editor. Now what we have to do is, as discussed, we'll be using stack. Why are we using stack? Because at any point of time, we need the retrieval of the last element that was called, right? That we were on. So that is why we're using stack, because it works on LIFO. Now what I'll do is I'll simply move over all of the strings that are present in my given vector, right? So I'll run a for loop. Herein I'll have two conditions, right? First will be that, see, as we know that the vector has two things, that is operands and operators. So first I'll check if at the given index, is it an operator, right? So I'll say if token I, that means at the ith index of the vector token, is it an operator, right? Or, so I'll quickly copy paste this here, right? Or is it an subtractor, that means the subtraction operator, right? Or is it for division, or is it for multiplication, right? So we'll not have this extra or, and let's change it to multiplication, right? So what did we discuss? We discussed that if we are getting an operator on the ith index of my vector, what I need to do is I need to pop out the last two elements, right? And then I need to apply that operator and push back the result to the stack, right? So what I'll do is I'll have something like int operand 2, because we know the second operand. That means, for example, if you write something as 4 plus 5, right? In mathematics, in the reverse Polish notation, it becomes something like 4, 5 plus. So I know if I have encountered a plus, which is an operator, then just below, just before, I'm sorry, the element that we had just before the operator would be present on the top of the stack. So it will be my second operand. So it is s dot top, right? Then I'll have something like s dot pop, that okay, I've taken the second operand, pop it out. Int operator 1, s dot top, and then pop out that also. After that, you can simply have if else conditions to check which operator out of the four was there on the current ith index. So you can have something like tokens I, if that is equal to plus, right? In that case, you just have to push operator 1 plus operator 2 into the stack. Else you can have an else if condition that if tokens I was minus, right? In that case, you have to push operator 1 minus operator 2. Else if tokens I is equal to multiply, right? In that case, you will push operator 1 multiply operator 2 into the stack, and simply at the end you can have an else condition wherein you are pushing operator 1 divided by operator 2, the way we do it in mathematics, right? So in this if condition, we have handled the case that if we come across what operator. Now, in the case of an operand, right? What is an operand? It is a number, right? But as I know, the given vector is of strings. So I'll just simply push it. But before pushing it, I'll convert it using the stoi function in STL C++. So I'll say whatever is present on tokens I, you convert it into an integer from string and push it. And then we'll finally return whatever is present on the top of the stack. Let's run it. I think we're good to go. Okay, looks like there's a problem. Okay, invalid operands. Okay, now let's run it. Okay, here, now see what happens is I need to access token I, that means the ith string and whatever is present on its 0th index also. So I'll quickly add a 0 here, right? So I hope you understand why I have done it. Basically, my tokens vector has different strings, right? In each string, you will have different elements, right? So any string can be of varying length, right? So I want to check for the 0th index of that string. That is why I've done this. I think we should be good to go now. Let's submit it. And it is working fine. See guys, it's very important for you to understand how to debug your code, right? You will know it only when you write it yourself, and every time you do it, you have a dry run that where is your code failing and what can be the possible solutions for it. Now let's quickly take this code and discuss its time and space complexity. But first, we'll have a quick dry run. Okay, so this was the code that we just worked upon. So let's take an example that has 4, 13, 5, divide and a plus, right? These are the elements that are present in my vector that has been given to me, right? I'll have something like a stack here, right? So what happens is I'll start iterating from 0th index, right? So when my I is equals to 0, I come across 4. I'll check for if condition and I'll see that none of it matches because it is not an operator. So I'll come to the else condition. I'll convert the string, the whole of the string into integer and push it into the stack. So now I have 4 and my pointer is pointing towards it. My iterator moves further in the for loop, right? I get again a value that is not satisfying the if condition. I go to the else, I convert it into integer and add it into my stack. I move forward, I again get a value that is not satisfying the given if condition because it is not an operator. We'll just convert it into an integer using the stoi function and we'll add it into the stack, right? So now when my pointer moves forward, right, my I has come till 2, and now it has to go to index 3. So when my pointer goes to the index 3, now this if condition is being satisfied. So I'll fall inside this if block. I'll say create an operator to variable and put it the value whichever is present on the top of my stack. So that is 5. I'll say after that pop it out. So this gets popped out from my stack, right? It is no more there. After that, create another variable operator 1. So as now my pointer was pointing to 13, operator 1 will have a value 13, and even this will be popped out. And now my pointer in stack will be pointing to 4. And I have these operator 2 and operator 1 values. Now I'll check for these if else condition. So as I know I have a division, so this will be satisfied. That means the else condition will be satisfied. So I'll have something like 13 divided by 5, right? So basically it would be, because we are considering the integer, right? So you will have something like 2, because very simply 13 divided by 5, 2 5s are 10, right? So you will get a 2. So this 2 will now be pushed into the stack. So 2 comes here, right? As soon as 2 comes here, now my pointer is again pointing to 2, right? It is no more pointing to 4, right? It will go to the, it was on the third index, right? It will go to the fourth index and now came across plus. As it is again an operator, we'll fall in the if condition. We'll get operator 2. In this case, it will be 2. We'll pop it out from the stack. After it's done, I'll create operator 1. Now, as my pointer is pointing to 4, as it is in my stack, I'll pop that out and put it in operator 1. Then as it is plus, I'll check these if else conditions. I see that yes, the first if condition is satisfied. So what is it? I'll say operator 1 plus operator 2. So that is 4 plus 2, which is 6. And I'll again push it into my stack. So now my pointer is pointing towards 6. Hence, my final answer will be 6. I hope this dry run is clear. It is a very easy question. Okay, so now let's discuss the time and space complexity corresponding to this code. Basically, here for this for loop, it will run for the number of elements that are there in my vector tokens. So supposedly it had n elements, so the time complexity will be big of n, right? Because if you see further, we are just having if else condition. If we talk about the pop or push actions, these are O of 1 time complexity operations, right? S dot top, S dot pop, S dot push, right? So the time complexity is O of n. The space complexity, as at any point of time, my stack might have a lot of, we cannot say all of them, right? Because see, but it can, in the worst case, can have O of n as the space complexity, because we are considering a stack, right? And why am I saying that is, for 2 operators, I had 3 operands, right? Okay. So this is the time and space complexity. If you want to discuss, you can always feel free to comment in the. Okay, so this is the time and space complexity. Feel free to comment if you have any doubts or you want to discuss something. Please like, share, and subscribe. Thank you.